Okay, so in front of you, everybody has a chart that looks like this. And you actually filled this out on your notes yesterday, except for you only went to 15, right? Did you go all the way to 20? Did you do? Some of you maybe did. But on the video that you watched yesterday, it only went to 15, right? Yes? Okay, so what we're going to do is we're going to fill in this chart all the way to 20. I'm going to write it on the board over here so that it stays up here the whole hour. I want you guys to write it on your paper, okay? So we're going to fill in the perfect squares. The root numbers are given to you 1 through 20. We're going to fill in the squares. So that just means we're squaring each number. What's 1 squared? 1. So fill in your paper. What's 2 squared?
4.
3 squared?
9.
4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64.
9 squared?
81.
And 10 squared.
100.
Okay, stop right there. Those hopefully are super easy if you know your multiplication facts. 5 times 5 is 25. 10 times 10 is 100. Okay? Now, hopefully, you have those all written down. Now we're going to fill in the little bit harder ones. I might need a calculator on some of them. Okay, 11 squared?
121.
121. 12 squared?
144.
Do you know 13 squared? 14 squared? 196. 15 squared? 16 squared? 16 squared is 256. 17 squared? 289. 18 squared? 324. 19 squared is 361. And 20 squared is 400. Okay, now the nice thing about this chart is if I ask you what is the square root of 289, well, you can look at the perfect squares and find 289. The square root of 289 is 17, right? So it's really easy to use that to find those nice numbers. Now, is that all of the numbers that are out there? No. Obviously, we can go beyond 20, but we did not add decimals on here at all, right? Every decimal can be squared. 3.1 could be squared. 4.1 could be squared. Okay, so we don't have any of those on there. In your notes packet, what we are looking at today is estimating square roots. Okay, so I don't want you using a calculator. The first question is to create a square that has an area of 4. So on the grid, in your notes, I want you to draw a square. Okay, now we have to think about a square has to have what? What does a square look like? All 4 sides are the same length. So I need a square that has an area of 4. What would that look like on the grid? Levi.
A box of 4.
A box of 4, right? So, right there. Agreed?
Yeah.
That is a square that has an area of 4. What is the length of each side? 2. Whoops. I don't want it to look like that. The length of each side is 2. All right, now let's create a square that has an area of 16. What would that square look like? On your paper, draw a square that has an area of 16. Brooklyn.
4 on each side.
4 on each side. Here's a square that has an area of 16. So each side length is 4. It's 4 by 4 because 4 times 4 is 16. Okay? Go to the next slide. How about an area of 36? What would it look like if I want an area of 36? Go ahead. 6 on each side. So 6 by 6 And we could count all the squares in the middle should equal 36. So the length of each side of the square is 6. So far, so good? Pretty easy? Okay. How about this one? A square that has an area of 20. Josh.
One side's gonna be 4, and one side's gonna be 5.
Okay, I'm glad he said that. Is that a square? So, okay, let me draw what Josh said. He said one side's going to be 4 and one side's going to be 5. But that's now a rectangle and I want a square. So, ooh, can't look like that. Because it has to be a square. Paige.
4.5.
4.5? Let's try it. I'm going to draw a square that's 4.5 by 4.5. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This would be 17, 18, 19, 20. Oh, there's a little bit more. Right, that's a little bit over 20, but is it close? How about we say about 4.5? Is it pretty hard to get exact?
Yeah.
Absolutely. Okay, we're at about 4.5. Okay, another way to write about in math is to do this. It's like a squiggly equal sign. That means approximately 4.5. Okay, now the exact is 4.472135955 and more. Okay, now let me show you how I got that. All of these I could have done by doing square roots. The square root of 4 is 2. The square root of 16 is 4. The square root of 36 is 6. And the square root of 20 is about 4.5. Now, I used my calculator to find out the exact. Today, we're not going to use our calculator at all. All we're going to do is estimate, okay? And this little chart that we just wrote is going to be a huge help. Without this, today's assignment is going to seem hard. If you have this chart in front of you, the squares and square roots chart, it's going to be easy, okay? I want to know the square root of 30 is between 2 consecutive integers. Name the integers, okay? So if I look at this chart and I find out where would 30 be, 30 is right here. 30 is between 25 and 36. Agreed? Okay, and if 30 is in between 25 and 36, that means the square root of 30 would be between what? 5 and 6. If I want to know between which 2 consecutive integers, it's between 5 and 6. Since 5 squared equals 25 and 6 squared equals 36, and 30 is in between there. Right? 30 is between 25 and 36, so it works. So the square root of 55 is between which 2 consecutive integers? Look at your chart. Where would 55 be on this chart? Go ahead, Maverick. 7 and 8. 55 is in between 49 and 64, so that means it's between 7 and 8. 7 and 8. Since 7 squared equals 49, and 8 squared equals 64, and 55 is between there. Okay, so far so good? How about the square root of 90, Ella? 9 and 10, because 90 is in between 81 and 100. So between 9 and 10. 9 squared equals 81. 10 squared equals 100. And 90 is in between 81 and 100. So far, so good? hopefully really easy to just look at the chart and find that. Flip the page in your packet. Okay, so now what we want to do is we want to be able to approximate these square roots to the nearest 10. Starting with the square root of 200. Okay, on this chart, on your squares and square roots chart, where would 200 be? Go ahead, Brooklyn. In the bottom down here, right? So 200 falls between 196 and 225. Agreed? So the square root of 200 is between the square root of 196 and the square root of 225. Well, by reading the chart, the square root of 196 is 14. The square root of 225 is 15. So the square root of 200 has to be somewhere between 14 and 15. So it's going to be 14 point what? 5? Okay, let's see. There's a difference of only 4 right here. There's a difference of 25 right here. If I say 14.5, that means it's right in the middle. Is it right in the middle? No, it's not. It's closer to what? Is it closer to 14 or closer to 15?
14.
It's closer to 14. So 14.2, 14.1. I would accept anything below 14.5. But it can't be 14.5. We understand why. Okay, it is not directly in the middle between those two numbers. It's a little less than that. Okay, you could have had, I would accept any of these. Any of those would work. Okay, recognizing that it's less than 14.5 but bigger than 14. Fair enough? Okay. How about this one? The square root of 30. Look at your chart. We've already got 30 here. So 30 falls between the square root of 25 and 36. The square root of 25 is 5. The square root of 36 is 6. That means it's going to be 5 point something. Is it closer? Which one's it closer to? Madison. It's closer to the 5, so maybe 5.4. Because this is a difference of 5 and this is a difference of 6. So it's almost in the middle, right? It's very close to the middle, but not quite. So 5.4 would be our estimate. Easy enough? Okay, square root of 99. What would I write down in these two spots? And everybody should be writing this down with me. If you're not writing this down, and you have to go do this on your homework on your own, it's going to be hard. Okay, Brooklyn.
81 and 100.
81 and 100. Square root of 81 is 9. Square root of 100 is 10. What would you say the estimate is? Levi? 9.9. It's almost 100. We're only 1 away there. We're 18 away there. So it's very close to the 10. 9.9 would be a good estimate. In fact, I would take 9.6, 9.7, 9.8, or 9.9, as long as you know what's bigger than 9.5. It's closer to that end. Okay? You try these two. See what you come up with. Do the same type of thing. Use your chart. Okay, so for the square root of 12, it's between what and what? Maria? Between the square root of 9 and the square root of 16, which is 3 and 4. Okay, so your estimate should be 3 point something. What did you put? 3 point what? 3? Okay, this is a difference of 3. This is a difference of 4. So it's a little bit closer to the lower end. 3.5 would be right in the middle. I would accept 3.1, 3.2, 3.3, or 3.4. If you had any of those, that would be correct. Okay, square root of 45. Levi. 36 and 49, which is 6 and 7. What did you put as your estimate? 6.6. This is a difference of 9. Over here, we've got a difference of 4. So it's closer to that end. You could have any of these. 6.6, 6.7, 6.8, or 6.9. Questions there? Okay, let's try the last two. Square root of 145, Jackson. Okay, so which is 12 and 13. So what did you put as your estimate? 12.1, perfect. I would accept any of these. As long as you know it's less than 12.5. Okay, last one, square root of 58. Brooklyn, go ahead.
49 and 64.
7 and 8. 7.7. Because it's closer here. This is a difference of 9, and this is a difference of 6. So it's a little closer on that end. You could also have any of those. Questions? Is this making sense? We're going to cross off the last slide. So don't worry about the last one. You can X that out. Okay. Then I want you to go to Canvas. Okay, log into Canvas. And go to your modules. And go to Tuesday and find the homework estimating square roots. Okay. On the instructions, it says do not use your calculator. You guys, you have this list. If you're using this list and you have this filled out, the squares and square roots, it should be extremely simple. Okay. The questions are pretty straightforward. For numbers 1 through 5, what two numbers is each square root between? Square root of 12 is between 3 and 4. You're finding the roots. Okay. So the square root of 27 would be between what and what? 5 and 6. Yeah. So you'd put 5 and 6. Okay. Use your time. I think most of you should be able to finish this during the hour.